Hello, everyone. Hey, all right, let's go. So, hey, everyone, how are you today? Uh, am I audible now, or is there still a problem with the comments? Can you notify me in the comments and we can accordingly proceed with? All right, looks good to go. So, hey, everyone, I'm Abhishek. I am one of the folks at Geeks for Geeks who likes conducting some system design courses. And today we are here to talk about chat applications. To be specific, we will be talking about WhatsApp to start with, and I will see if I can extend it to a few other chat applications if time permits. All right. So a very quick check, if you can help me with a simple yes or no. How many of you have attempted, say, a few chat application system designs in the past, or have had a certain amount of fear or comfort zone when it comes to reacting with them? Just a quick, simple hi, hello would work. In the meanwhile, I'll just put up my screen on share and we can start from there. Okay. So today we are here to focus primarily on the problem statement, which is design WhatsApp. Okay. So what we'll do, uh, good. Good to know that few of you have had interactions with it in past in some interview or some practice sessions. So for today, we will continue working on a very simple framework. We'll first list down the functional and the non-functional requirements. We will then list down the certain amount of capacity estimations, what will be the requirements that will be required for uh, building the overall systems, and for a certain number of folks. So I have seen a few comments coming like, I have no idea about HLD or how overall the system design question works. And what we would do is, I will anyways, after completing the system design, we'll walk through a very high level system architecture, as well as a certain amount of API designs and how we would store uh, data here. Uh, no, for questions around where I work or what if I'm an employee of Geeks for Geeks, no, I'm not an employee of Geeks for Geeks. I interact and partner with them for a couple of my courses on, say, WhatsApp or some other topics here and there. But officially, I work at Google, and I am been with other product companies such as Flipkart and Walmart in the past. That's a very brief history about me. Feel free to hit me up over LinkedIn if you have any follow up questions, and I'll be very happy to interact with. Okay. All right. So, with all of that being discussed, let's go ahead and list down a certain set of functional and non functional requirements. What I mean by functional requirements, by the way, because I understand that some of you may have been having this as a first interaction, is what are the core things that you want your system to be doing? Okay. And we will be listing it down over here. So, when we talk about pure system design of like functional requirements, right? Uh, if I'm talking about design WhatsApp, the first and foremost feature will be sending and receiving messages. Uh, Sending and receiving messages. If possible, I would want to extend it to a group, but I want to limit it to one-on-one messages as of today. Uh, and group if time permits, let's say. Let me indent it a little bit so that it becomes easier to read. WhatsApp also, we know that has an ability of showing sent ticks, delivered ticks, and read receipt. So we'll call it that. I would want to showcase you how we can do that. And also we would want to share multimedia files. What I mean by multimedia files are things like images, videos, documents maybe, etc. All right. So these are some of the topmost functional requirements that I would want to stay on top of before we go ahead and list it. And that's what we'll be focusing on. In terms of non-functional requirements, now that we are there, what are the things that we would want to do? So non-functional requirements just means the non-technical stuff, things like what would be the load on the system, how many people would be interacting with it, Do you want your system to be available throughout the day, or like is quality matters over this? Okay, so what we would do is we would target high consistency. The reason why I'm saying consistency, even though WhatsApp is supposed to be a highly available system, is my screen blurred to the rest of you as well, or should I? Let me just see if I can zoom it up a little bit. Uh, is this zoom fine, or do you? I'll just take a pause over here to ensure that the zoom level is fine. Hmm. It is fine. Cool. Thank you so much for letting me know about this. So, the reason why we are talking about high consistency is it's very important to understand what is the order of the messages in which it was sent across. Imagine how much of an inconvenience will be if you're sending the messages and it's going in incorrect order. The entire conversation experience will be dampened. Also, we use WhatsApp on multiple devices at times, and sometimes it would not be a good experience if you are able to see a different order of messages on different devices, and we would want to not have that problem overall. So consistency matters primarily because the sequence in which the messages are sent across definitely matters a lot. The other thing is there has to be low latency. We all want our messages to be sent across as quickly as possible, and howsoever we quickly we can relay it there is matters. High availability is also important, but we know CAP theorem, which states that we will have to pick up in between consistency and availability, knowing that partition tolerance will be obviously required for an application as huge as WhatsApp is. So whenever there's a conflict in between what to prioritize, I would always prioritize consistency over availability. But I definitely don't want WhatsApp servers going down. I mean, none of us would like that, right? So that's pretty much all about it. I would continue with, say, capacity estimation, which is what I said we will be doing to start with. What I mean by capacity estimation is I'll be making a few random guesses around how many messages we send per day, what's the size of a message, etc., and how much storage space I'll need. So let me take a very quick stab at it. WhatsApp currently has, when I last checked, it has roughly 2 billion users, which is, oh my God, quite a lot of users. And let's say we send across 50 messages throughout. So I'd say we have 100 million messages being sent per day. That's a lot of messages. Right now, 100 billion messages per day uh, into let's say each message is roughly 100 bytes. Normally, if I'm in an interview, I would ask validate these facts with an interviewer. But since I'm on my own today, so I'll just randomly make a few guesses here and there and continue on top of it. So it's roughly 10 terabytes of data per day. It sounds like a lot, but considering that WhatsApp has too many active users, it's a fair enough number. Uh, WhatsApp has a data retention policy that if you don't receive any message in 30 days, I would go ahead and delete that message, basically assuming that the user no longer uses WhatsApp. So I'm roughly looking at 30 terabytes of data per month, which is what we will be going ahead with to start our overall calculations. Okay. And I think this much is overall fine to for me to take a pause. This is how I would even approach, even if I was doing an actual interview or explaining the component to someone. I want to define the scope of the problem. What are the features that I intend to build around the constraints, which is listed in the non-functional requirements, which I'll try to achieve, and a rough, very quick calculation around what is the appropriate database size or file storage size that I would be requesting from the necessary hardware infrastructure teams for me to go ahead and build this application. Fair enough. Uh, I'll take a quick 30-second pause or 10 seconds pause over here, and then I'll walk you through a very high level core design, and we'll kind of follow it up with a API schema in general. Any doubts, any questions before we go ahead? No, right? Okay. I'll keep monitoring the chat in meanwhile, but let me quickly walk you through some of the core features. Okay. So what I want is All right. So let's say there are two users. Okay, let's say there is user one and we have a user two. Okay, now they both want to send messages to each. They both want to send messages to each other. Fair enough. Now, how would that normally happen? We'll have a chat server somewhere, which is WhatsApp's chat server. This is how we would start with. And the moment user one wants to send a message to user two, it'll send a message to chat server. The chat server will then send a message uh, to user two, which will be received and acknowledged. And in the meanwhile, I'd want to store it in some database so that I don't lose out on my messages. Fair enough. That's how normal regular flow would look like. Now, this is fairly simple, right? This is without any problems and complications, any scale, anything being brought into. Let's spend a minute to try and understand how we would go ahead and actually implement this with all the read receipts delivered and act status which we are talking about. So going sequentially, we'll have user one, which sends a message, let's say a very simple message saying, Happy New Year. The message could be something like Happy New Year. All right. It sends a message to the chat server. The chat servers would then send a tick back to user one. Let me make it dotted because I tend to keep deleting it. So as soon as the moment the message reaches the chat server, the chat sends back an acknowledgement message to it, which would indicate that the message is marked with a single tick icon at the sender's end, saying that the message has been sent. Once the user two comes online, it fetches the message from the chat server and then sends an acknowledgement back to the chat server saying, hey, I received this message. All right, so let me make this charted. And it again sends a received at message. As soon as the message address is sent, this is also updated to user one via a push notification. Let's just say the chat server sends another request saying delivered ACK. It's still not talking about read. And when the user actually comes online, it'll send one more acknowledgement. This time it will end up becoming the received ACK message to notify that, hey, I actually received the message. Okay, this is doing some frenzy things. So this will be like red acknowledgement. And the moment the chat server receives the red acknowledgement, it will also go ahead and communicate the same to the user one that, hey, your message is now read and received. So this is red act, right? So this is like a multi-tier architecture that people go through and interact with. Uh, and that's how they normally go ahead with. The tool that I'm using is Whimsical. Let me just type it out over here so that you can refer to it later on. But it's Whimsical. I like the user interface of this tool, and it's easier to draw on this, I think. Okay, so this is how I would maintain the send, read, and delivered receipts, and how I would send messages across in a simple word. I wanted to cover this so that we don't get distracted around the core basic functionality once we start bringing in the scale and the other components around this. Okay, I know WhatsApp has end-to-end encryption to start with, and I would not want to store messages in this. So what I would do is I'll keep it as a temporary database, something which would support a lot of read and delete operations, fast delete and lookup operations. And I'll tell the database that WhatsApp uses later on. Let me just hold on to it here. So the only time when I would want to store messages onto a database is if, say, user two is offline, because there's no guarantee that the user two will always be online, and I don't want to store messages in a chat server where the probability of losing it is very high, considering that a server can crash at any point of time overall. Okay, so with now all of this being discussed, as soon as the message is delivered, I would delete the message from the database. Till then, I would keep it here. So in order to simplify what I want to delete and what I don't want to delete, like I would send every message to the temporary database. And then as soon as I receive the received app message from the chat server, or basically from user two onto the chat server, I would go ahead and delete my messages from the temporary database to ensure that we are adhering to the end-to-end encryption protocol. Okay. All right. So, so far so good. If this is done, then I'd walk into the additional scale component of my design of how I would do things at scale. Okay. In terms of anybody who is asking me which is the tool that I'm currently using, the tool is Whimsical. Feel free to Google about it, or I've also put up a link of it on the portal. Okay, and thank you for pointing this out. Okay, cool. So now that we are done with the core basic functionality, let's jump into how we would do things at scale. Before I do that, let me actually discuss about a certain set of APIs that I would want to write and discuss that also so that we can get done with it and then we can focus on the code part. So in terms of the APIs, right, and I'll try to keep it simple again for my personal satisfaction. So in terms of APIs, what we can do is let's look at the things that we want to. I would want to have a messages API, which would be a post call, sorry, which would be a post call. And what it would do is it will call a send message at the back, which should have things like sender ID, receiver ID, who is the one going to receive the message, the type of the message. If it is a text message, I'll enter the text over here. If not, if it is a media file, I would basically go ahead and do this. Okay. So this will give me a message ID and I can actually receive a message ID as a response back. This message ID is what I would be using to exchange all these app messages that I have drawn on the screen here. Okay, so with this being done, the next thing which I would want to API which I'd want to have is how do I fetch a message? So I'll have a endpoint called as get message, which now becomes a get protocol, obviously. It would end up calling a get message service with a user ID. The user ID in this case will be the person who is receiving the message. So it will actually be like a current user ID. And what it will do is it will hit the chat server. It will fetch all the unread messages from it and dump into your phone. Okay. The same thing goes for media objects. We'll have talk about two things. So when I'm uploading, I'll make a post call. The post call will call this method called as the upload media. Let's call it this, or to simplify it, let's just call this upload file. Okay. And what I would need here is things like file and file type. And I would return a file underscore ID. I may even want to have, say, a sender ID, but then I'll have it already over here. So I would not want to duplicate this twice. While uploading, I don't want to check which is this. It's technically a send message feature itself with a file attachment to it. While downloading, the same thing. Okay, so we'll again hit get media / media post, this time as a get object endpoint, and I'll hit the download file. Let me make this proper. For a user ID followed by file followed by a file ID. Okay, the user ID is primarily because I want to store somewhere who the user is, and because this time I'm not doing get message again has a user ID, but I do definitely want to have the file ID here is why I'll retain it, and I'll get the file object from here. Okay, so without diving too much into detail, this is how my API design would eventually look like. I'll take a very quick look at the time. We are 20 minutes into the system. All right, so far so good. Okay, with all of this being discussed, okay, we have still not brought in any scale component into the picture. This is all happening in between two users with one single chat server, which we know is not going to be correct implementation and how we go ahead with it. So let's focus our energy on how we would send messages here and here. There are two options. If we go by this, let's look at the number of dots that I had to establish for me to get this object, this line, and all the acknowledgements that we have been discussing. Considering we are sending across 100 million billion requests, and I have 1, 2, 3, 4, 5, 6, 7 calls being made, I am looking at a humongously large number of API calls that are being made, and we can obviously agree that there's scope of optimizing it. So a single direction mostly signifies a TCP connection, right? TCP is from a client to a server, and that's how we fetch. Now, while sending the message, I can still use TCP, no harm, because I'm sending messages one at a time. But while receiving the message, if I want to consistently keep a low latency architecture, I would have to send a get message TCP call every now and then. And when I mean every now and then, I may want to send it, say, every 10 milliseconds or every 50 milliseconds or so, or maybe every minute, which is also too late for an instantaneous chat message if you are saying chatting frantically with your closest friend. Uh, so the number of API calls that will be made will be too high if you go ahead and with a TCP connection. What we can do is we can make the TCP call wait by a fundamental called as long polling. Okay. So what long polling does is, let me try and explaining it over here in a parallel diagram. I'll delete this later on. Okay. So user is here, sends a message to the chat server, waits for the response to come through. I'll just drag it here. So it waits for the response to come through. And if it comes through, then well enough. If it's not, it does the exact same thing again and again till the time it receives a message. Too much of a tiresome problem to solve and too much of a headache. It waits. So long polling, it waits for a certain amount of time. Let's say I want to wait for say 20 seconds before terminating this connection over here. Okay, or basically the receive connection over here. That is still too much of resource wastage if say you're not chatting or the user is not even online. And considering the total number of users that we have, the extent will be huge, right? So what other thing can I do apart from trying to do long polling? We have a component called as WebSocket. What WebSocket does is it allows the server also to instantiate a connection with the end user. So unlike a TCP connection, which is unidirectional, goes mostly from client to server, WebSocket connection is bidirectional, and we can use that model to for the servers to be able to push notifications to do it. So how would the world look like if I'm going ahead with that? So what I will do is I will move this diagram down and I'll use the space here to go ahead and draw my drawings. Okay. So again, I'm going to do the same user one and user two implementation. So I have user one and I would have user two over here. Both of them will interact with a chat server. But this time what I will do is I'll have a WebSocket chat server. So WebSocket chat server. And because I know I'm looking at a lot of people using WhatsApp, I'll have a scaling distribution. I'll have multiple servers which are trying to take the load. As soon as you have more than one server involved in your overall design, that advocates for a need for, say, a load balancer being brought into the picture. What the load balancer will do is the load balancer will distribute the load evenly in between the two or two plus servers that we have, and we'll take it up from there. Okay, so that's how this would look like. Let me just clean up my code a little bit. Okay. So this is how it would look like. Okay, now the chat server will need to know where to send the message. For example, user one wants to send a message to user two. Okay, and I agreed that this will be bidirectional. So let me make this bidirectional because it's now a WebSocket connection. All right. So what would the chat server want to behave like? User one sends a message, which needs to be instantaneously relayed to user two. Because I have more than one server here, there is absolutely no guarantee as to which place I would need to send my message to. We don't know it, right? We don't know where the address is. Okay, so in order for me to determine what will be the address, the WebSocket chat server talks to a component called as a WebSocket manager. Okay. So we'll have a WebSocket manager over here. Now the WebSocket manager, again, because there are too many servers and we will have to basically distribute the load here, I'll bring in one more load balancer over here. Primarily to just distribute the load on the user side versus this. The reason why I'm using two dedicated load balancers is primarily because I want to ensure that I scale this, which is directly interacting with the users a lot more compared to how I scale the second half of my problem, which is just talking to a WebSocket manager. Now, the WebSocket manager maintains all the metadata with respect to which client is connected to which WebSocket chat server and etc. And because this information does not need to be persistent, we can always create it in this. What I would do is I'll use a cache. So I'll use a Reddish cache for this, for managing WebSocket connections. All right. So this is what the purpose of this Reddish cache will be. Okay. So now we know the WebSocket manager will return the address of user two, and the message will be exchanged back and forth. So far so good. I'm now able to send a message and I'm able to receive a message uh, without high latency because I'm using WebSockets and I'm able to get it done instantaneously. Cool. So what happens next? What if I'm say continuously chatting with my friend? What would happen? I sent a message, and then 2 seconds later, I sent another message, and 2 seconds later, again, I sent another message. Would I want? I would not want to go back to the WebSocket manager every single time, right? Primarily because I know I just had that address, and I would not want to lose that address instantaneously or make unnecessary calls to the WebSocket manager. So what I would do here is I'd maintain a cache internally at the server level itself for the address which is received, the timestamp at which I received the address, and the number of open connections that I'm having at my own layer, so that I don't need to reach out to the WebSocket manager. So let me just bring it onto the board. So chat server cache. It will technically be inside the server, but just to be verbose, I want to explicitly write it down over here. What I'll do is I'll move all of this down a little bit, fix this arrow. Oops. Okay. And I will also scale it at the same level I have this. So this basically just talks to this internally because they are within the same server. There's no open connection here, like a remote connection going on here. All right. So the question that now pops up is, what happens if for some reason the connection in between, say, the chat server and the user two would get disconnected, right? We don't want that to happen. But it will happen. We can't avoid it. But because I've cached the address, which means that I'll now be looking at an incorrect address and the person has already moved from house A to house B, uh, and creates a new connection. The moment the new connection is created or the connection is terminated, the WebSocket manager will go ahead and notify the WebSocket chat servers that, hey, this address no longer exists. And what we'll do is we'll invalidate the cache here, saying that, hey, let us drop this particular person's address because that person does not live there anymore. Okay, so that's how I would handle sending messages. My functional requirement point number one in here of sending messages across point A and point B. Okay, obviously because I'm sending messages, and I want to ensure that there are consistency requirements here. What I would do is I'll back it up with a dedicated export service called as the message service. The message service is just fairly simple task, nothing out of the ordinary. What it does is it stores the data into the database, the same database which we had referred earlier down here, that I don't want to lose my messages. Because this database does not have to be persistent. So I know WhatsApp uses is a database called as Amnesia. The reason why they use Amnesia is it supports very good delete ability, very good write ability, and has a very fast lookup because I'll have like a multiple millions and billions of messages reaching here. I'd want to look it up by the user ID or the message ID or the sender ID, and I would want to delete it based on sender or receiver IDs, receive status. Okay. I also want to ensure that I do not leave the sequence of the messages broken. So I'd use a Kafka as my internal messaging queue, and I'd want to continue with building on top of it. The reason why I would do this is because we agreed that I would stick to my high consistency requirement, which is mentioned over here. And Kafka allows me a first in, first out messaging sequence order so that I'll know that I'll always retain the messages in the order in which I have initially received, with or without the user being connected or disconnected at the receiver's end or the sender's end. Whichever message reaches the server first will be what will be relayed to the user at the end of the day. Okay. Uh, the flow chart would look something like this. So the message reaches the message service. I pass that message to the database. As soon as the user two receives it and sends a received ACK, I go back to the database and delete the messages from the database. I also want to ensure that I have absolute end-to-end encryption enabled. which is what WhatsApp promises us. So I'll also go to the log files and delete the data from the log files and ensure that I'm not maintaining any copy of the data at the backend, and continue with it. Okay. So far with me, we have covered the messaging part of our process completely. Uh, a quick time check from my end. We are approximately 33 minutes into the system. We have to go through sharing the multimedia messages, and we'll focus in the next few minutes over there. And if possible, I'll also talk about group messaging after this. Okay. So, what next? We need to do handling of the message service. So once the user creates a particular message, right, with a file type attached to it. So let's say this is the media service. Apologies for the typing mistake. Okay. So the load balancer would pass in a queue over. Okay, get my arrows right. Cool. So when the user wants to send a message, it will be a file type object. I would want to store it into a particular file storage. Let's call it blob storage, the standard term of it. It could be S3, it could be anything else. It depends on which cloud provider you're interacting with. So as soon as I receive the media file, I will hit the post upload file method to invoke the media service. I'll store the file type here. I would also need to store the metadata of the file, which I'd store in the Amnesia database as a part of the basic service. And we know we all keep receiving certain messages which go viral, be it in the form of images or videos. If it's around New Year's, there's too much of Happy New Year messages floating around. I would not want the user to receive a huge delay on receiving messages. So I'll use something called a CDN. It stands for Content Delivery Network. What it does is, if you want to download a famous media file, it brings that file closer to your location in a server which is very close to your location, so that you don't have to go back and fetch it from a very high, far off distance. Right. And that's how we would want to go ahead with using this service in general. Okay. So we continue doing this, and we continue going up and beyond our standard server location to bring the files as close to the user's location as possible for them to be able to download it in real time. What I would do here is, I don't want to duplicate the number of files that I have been storing, because storage is very costly. We were looking at 300 TB per month worth of storage, which is a lot. And this is only for 100 bytes of messages being sent across. I'm sure a media file will not be 100 bytes. It will be much, much more than that. Depends on what type of file we're sending across. We can try putting up a limit. Let's say we put up a limit of, say, 50 MB as the maximum upload size. We are still looking at much more than 300 TB per month of this. So we definitely want to ensure that we don't copy and paste the same file because it's being uploaded to multiple users. What way we can do it is, we can hash our code. Basically, we can hash the files which are being uploaded, keep the hash in a lookup table, and every time a new file is being uploaded, we first convert the hash of it, check it into the lookup table and see if it exists there. If it exists, good enough. I will not upload it. I'll just return the file ID to the sender, and the file ID I already have, because I have it uploaded with me since the very beginning of time. Right. So that way, both my uploads seems to become faster because I already have them, and also because I'm saving space. I'm saving a lot of money for my company. Right. And the CDN helps me deliver and return it quickly. Okay. The question that now I think I missed out on and I would want to debate is, where are my users in this entire database? So I'll use a user service which kind of interacts and fetches all of this. Again, the load balancer will do the talking for me with the user service. And what we do here is, the user service can just interact with a simple database. Let's just say I'd use a MySQL DB over here. Okay. Which basically has the metadata for all the users. What I mean by metadata is things like phone number, which is the primary key in case of WhatsApp. And what we can do here is the phone number, the name, the image icon, which is the profile picture that we have, is what we would want to update. Okay, so this, we will be using the users table. And because this information does not change every now and then, I would want to keep it with me. Okay. So far, so good. We're doing pretty good on time. I think I'll be able to cover a couple of more features, things like group messages and things like how to show the last seen timestamp. Or if you talk about Facebook Messenger in this particular case, or any other messenger in this particular case, they show if the user is online or offline. I'll see if I can go ahead and cover that as well as an extension to this particular design. I'm hoping you're finding this design simple. I know I'm adding components after components, but I'm trying to keep it simple at my end. Okay, so let's go ahead and focus on how group user behavior would look like, right? If I have to think about it, I would I'll move this further down to create more space. And let's say we are looking at groups. So if I'm looking at groups, I would want a group service. Again, I love creating services. Okay, like microservices is a good thing to do. So the group service, what it does is, because it's talking to users, I'll just make it talk to the MySQL DB itself without. Can you? This is like a super bad. All right, this is better. Okay, so what it will do is it will talk to the group service. It would also want to talk to this. And what I would store in my groups is something like, let me put up a text over here. So you can have something like group A, and you'll have user one, user two over here, right? So user one, user two, maybe a user three also. Feel free to have people with two groups. So you'll have three users, you'll have a group. Each group will have its own ID. Let's call this as group ID. So each group will have a group ID, a list of users, list of user IDs, and that's it. Now, a group can be treated as equivalent to a Kafka topic, which you can go ahead and subscribe to. So what we will do is, when we are trying to relay messages in a group format, we'll use the famous publisher subscriber or the pub/sub model of sending messages. Let me actually type it out here. To ensure that we are able to explain the components to the end users correctly. The sender of the message, whosoever the person is, will publish a message into the Kafka messaging queue with a group ID attached to it. And Kafka, because Kafka likes maintaining the metadata for all the topics/groups that it has, it would then send out a message, which is the message which is sent by, say, user one to user two, three, four, five, blah, 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 right? That, hey, I received this message, you're supposed to receive it. And what we will do is, instead of sending the message directly, we'll use the message service so that we are able to do the received, delivered component of it. As soon as the message is delivered to all the participants, we'll call it as delivered on the user screen. Otherwise, it's always like sent, and you can click individually and show it. So the group service will not have any new components being added to the table. We'll use leveraging components. I'll talk to Kafka. Let me see if I can draw additional lines over here for my sake of doing things. I really want to bring this out. Okay, this looks ugly, but unfortunately, this is what it is. So we'll talk to Kafka on this front for sending the messages across, and Kafka would eventually end up relaying the messages elsewhere. All right. So with this, we are done with how a group message would eventually look like. The same thing if you want to go and talk about showing the last seen message, right? So the last seen message can be tracked. No, sorry, the last seen status update. It can be tracked with a simple metadata storage. So we know the WebSocket manager is always maintaining the live connections, and this. We can use the WebSocket manager to publish data into a different cache this time. Let's call this, what do I call it? Let's call this as last seen / line status cache. The reason why I'm calling it last seen slash online is because I want to keep it generic enough for anyone who wants to understand it. Okay. And the WebSocket manager, every time it creates a new connection and terminates this, can go ahead and update it. Okay, that hey, this was the time it last saw a person. And then you can basically sending the response back is a simple status update, and the user can just fetch, depending on which user ID screen you are on, by passing the user ID message to this. So it would be something like a get message. The only thing is, in this time, the message that you're trying to receive is at what time did the user update his last seen status. Okay. So with this being said, we are pretty much done with whatever I would like to highlight. We are good 43 minutes into the system. If you have any questions, feel free to post it into the comments, and I would be happy to pick it up and discuss more around it. In the meanwhile, let's just quickly take a very quick look at my design and see if I accidentally missed out on something while we were discussing and debating about this. Okay. So do let me know. I'll keep an eye on the comments while we discuss. Okay. While we do this, so just to reiterate the list of topics that we have been discussing, we spoke about. Let me find this here. So we spoke about things such as low latency. We can keep minimizing our latency as and when we talk about this. Uh, a simple way is by geographically distributing our WebSocket servers and the relevant cache that is associated with those things around the globe in even format, so that when user one tries to connect to a particular server, the server is not located very far off from them. We can also use Reddish cache uh, at multiple services level to ensure that we have enough latency requirements around this. And we're obviously using CDNs for our file service, right? That we are downloading files from the closest possible servers. The consistency part, again, is important. I'm just going sequentially through my non-functional requirements because it's the most easy one to miss while designing systems. And Abhishek Jan, I just saw your comment. If you have anything, please shoot. Okay, so if you're talking about high consistency, we definitely want to use a FIFO messaging queue with, say, strict ordering enabled. The strict ordering is a feature that comes as a configuration parameters in a lot of our messaging queues. Uh, or we can use a sequencer type of an argument. Is this for Android development? So we didn't talk about the front end part of it. This is more around how the messages will be handled at the back end perspective. You can always expose it as a front end or a back end application, depends on how you want to look at it and expose this. Okay, so this was the question which came up. Is this for a front end development and Android development? You are more than welcome to write an Android SDK app on top of this and build it on top of that backend layer. We did not bring in any front end layer into the discussion. It's more about what are the APIs that I'm exposing and how do you invoke it. I hope that answers your question, Abhiraj. Cool. So, anyways, continuing from there, uh, when the user is offline, that's the place where in we'll have the maximum amount of risk of the messaging sequence being halted, because again, it takes time for a user to come online, send messages across. The user can be offline because he's genuinely offline, or he's in a area where there's no service and there's nothing stopping the user from sending a message while he's offline. But then the sequence has to be maintained in the order at which the server receives the messages, and they are then sent and relayed to the recipients across. Okay. We can always make the system highly scalable by adding in more website chat servers and WebSocket managers. We can even replicate them across multiple data centers and geographies to ensure that we have enough fault tolerance built into the system. Okay. As soon as a user is disconnected due to a certain fault in the WebSocket layer, the session is recreated using a load balancer, but the recreated session can exist in a different server. Okay, and thus the WebSocket manager becomes extremely critical into resolving all the dependencies around it. Okay. Uh, in terms of how I would want to replicate, I would prefer using a primary, like a leader follower replication model, because it allows me to optimize for writes and at the same time keep reading messages here. There are multiple different ways in which we can relay messages. I would want to basically ensure that I write to maybe one leader and few followers, or maybe multiple leader and few followers on top of it. Okay, so that's pretty much all I have for today. Any other questions? Any trade-offs that you found difficult to understand, or you found it hard for me to explain? Feel free to reach out to me over LinkedIn, and I'll be very happy to go ahead and discuss it. Okay. I will pause here because I know it takes time to write, so I'll maybe take a pause for another 2 to 5 minutes, and then I'll end the session. Share my LinkedIn. Um, okay. I'm not sure if I can do that right now. I will have to double check it with the Geeks team. But you can always just type Abhishek Kumar on Google and stuff, and you'll be able to find it. Let me see if I can drop it here. Any other questions apart from this? Then thank you, everyone. Thank you so much for your time and for dialing in. Appreciate the help and best wishes. Okay, I have one more question. Let me see if I can quickly bring it up. This is new for me. So, how can you learn more about high level design? You can learn a lot about high level design from multiple sources. Geeks for Geeks itself has a system design for layer, and you can always refer to it. Let me see if I can quickly share the link for the same. So, Geeks for Geeks design. And just to reiterate, so most of the system design interviews that we keep talking about, uh, they are primarily for senior software engineering roles at product companies, as basically any company in general. And you're more than welcome to have this. So, for example, Geeks for Geeks has this. There are other good resources also, like Grokking the System interview and other places which you can refer to. But I personally like Geeks for Geeks for both coding and non-coding work, basically system design and other types of articles to read it. So Rahul asks a question: Can we have or can we have only one load balancer here? Yes, we surely can have one load balancer. The prime reason for having two was because I wanted to scale the chat server with a different configuration and my internal API services with a different scale parameter. Also, I don't want to expose the external load balancer to the rest of the world. I want to ensure that level of security and abstraction is maintained so that people cannot play a foul play here. And I want to keep the second one internal, which is directly interacting with all of my internal microservices, which we have built. Okay. So that's pretty much it. Any other questions before we wrap up? Aditya, do you have a question? I just saw that you had a message. Mm-hmm. Okay, so there's this question around how can we learn about HLD for free? There are too many options available for learning anything for free in this current world. You just have to tune into a couple of resources. If you like reading books, designing data intensive applications is a really good resource. However, it's a fairly costly book, is what I would assume. Um, if I talk about online sources, Geeks for Geeks, and other portals are really good. You can also tune into a certain set of YouTubers. Unfortunately, I'm not one of them. And you can always reach out to a set of famous YouTubers who talk about coding or system design in general, and you can interact with them. Okay, that would help you also in learning about this. And a lot of people love writing blogs and a few other things and how they want to go ahead with it. Okay. Okay, this last question: what's the future of React Native app development? I'm so not the right person to ask about this because I specialize in backend development. And this that being said, I know about a lot of good companies and products which use React Native, and I hope it's a good thing. But again, I've never worked on it, so I'm not the best person to talk about this. Uh, okay, you want me to talk a little bit more about WebSockets? Okay, sure. So see, WebSockets, right, is a connection protocol just like TCP or something else there. What WebSockets is uniquely designed for is for chat applications, okay, or wherever you have consistent streaming. A server, up until prior to WebSockets was invented, a server did not have the option of invoking a connection with the client. So only once a person, a client in this particular case is the user, unless and until the user opens up the application and sends a ping to the chat server, they will not be able to access it and resolve messages from the server. Okay, which was a huge limitation, right? Think about pre-WebSocket world, how many useless API calls we were making just hoping that I would receive a message. Okay, it's more like okay, so I'll take an example from my childhood. I used to love ice creams, right, in the summers. And at 4 o'clock, I knew that the ice cream vendor would pass through my gate. So I used to keep running back and forth, hoping that I would be able to catch the ice cream vendor. It would have been so much simpler if he knew where I lived and he would have just come knocking on my house, uh, saying, "Hey, the ice cream is here." So that's the same type of a reaction that WebSockets provide. WebSocket allows the server to send messages to this. Every time you wake up in the morning today and you see you have messages in the form of app notifications waiting from so many apps on your phones, it happens through our component, which is the WebSocket injections, or the app wakes up every day morning and sends it across. However, the app has been designed, it's more like a pull based versus a push based model that helps us. Okay. The other question is uh, what is the architecture which is used over here? So I didn't use any explicit architecture which is here. I split my APIs into multiple services: the WebSocket, message service, media service, user service, and group service. That's pretty much all about this. I was consistently trying to keep the design simple, and I followed a framework. The framework that I normally like following is I want to design my core applications with, say, a very few users, 1 to 10 users, wherein I first focus on getting the functionality right. And then I start diving deeper into the non functional requirements of how I bring in things at scale and how I'd make my business grow according to the number of users who are subscribed to it. All right. So that's there. The other question which I have, which is not related to this session, but it's still here, is what is Firebase? I didn't use it in the session, so I'll just do a very quick high level walkthrough about it. It's more about how do I put it? I basically have used fast Firebase to get my apps up and running very quickly with a basic managed infrastructure. It's provided by multiple cloud providers that we can exist about. Feel free to go and take a look at it. I mean, because this is not a topic for today's discussion, is why I'll not be able to dive deeper into it. But I just wanted to do a quick skim about this. All right, we are pretty much about to be on time. Anything else that we need to go? Okay. Thank you so much, everyone. Really glad and happy to interact with all of you, and I hope you found this helpful. And thank you so much. I'll terminate the session now. Thank you.